Hello, everyone. Welcome to the TERSUS webinar. I'm Min Chen. Today, I will introduce the TERSUS new unmanned surface vessel, the DUCK. I will introduce this USB to you from the following three aspects. The DUCK, the TERSUS Captain software, used to remote control the USB, and the Marine Bench View software, used to post-processing the depth data. First, let's get to know the DUCK. The DUCK is a smart, efficient, and productive unmanned surface vessel equipped with a single beam echo sounder. It provides a fast, dependable, and portable solution to perform bathymetric surveys in various environments. With its advanced capabilities and user-friendly design, the DUCK is a powerful tool for professionals in bathymetry, offering high accuracy and precision in the collection of positioning and depth data. The DUCK is sure to meet your needs. The slogan of the DUCK is "The DUCK floats and the depth fixes." It uses two words of RTK solutions, float and fix, to describe the DUCK's ability to accurately measure water depth by simply floating on the water. And let me show its smart design. It's 1 meter long, around half a meter wide, and a third of a meter high. The whole design is M-shaped, which makes the USB more stable and flexible than the triple-hulled vessel. And the weight is 7 kilograms without instrument and battery. The material is high-strength PP alloy, and its anti-wave and wind level are 3 and 2. Its waterproof level is IP67. The power of the DUCK is strong. It comes with a rechargeable lithium battery that has a high capacity, and there is an additional backup battery available. So you have two batteries. And the max speed is 7 meters per second. Now I will show you a real video to demonstrate its strong power and fast speed. Let's check the video. Okay, and here is another video, real video, showing its stability and flexibility. Let's it's a previous test. We ran it in manual mode. The fast speed. The steering is smooth. Okay, let's move on. The DUCK is equipped with two plug-in mantle ducted propellers. Okay. 6 hours. Someone asked that question. I will answer it. Uh, the DAC will work with one battery. So if one battery is dead, you can remove it and replace another. So two batteries means 12 hours. One battery means 6 hours. Okay, let's go ahead. Mm, it's equipped with two plug-in metal ducted propellers, and the propellers are at the same level as the bottom of the hull. I will show you the previous picture of it. You can see this picture. The propeller is at the same level of the bottom, so they can effectively reduce the risk of entanglement with fish nets, water plants, and surface debris, and enhance operational safety. Let's see its seamless data transmission. It supports real-time peer-to-peer transmission with two omnidirectional 2.4 GHz RF antennas, and the remote control range is up to 2 kilometers. And the camera's field of view is 120 degrees, and its resolution is 1080p HD. And it also supports auto return when signal loss. One of the most important features of the DAC is its expanded capability. You can connect an Oscar TAP just receiver to it and implement the PPP function. It can realize centimeter-level satellite-based PPP worldwide without setting up base stations and connecting to on-chip service. The DAC is unrivaled in rivers, lakes, and offshore areas with no or poor network coverage. Also, you have other options like Oscar Basic and Luca. You need to confirm the type before the shipment. Okay, let's introduce the ES200 single beam echo sounder. There are two different range and frequency types, 100 meters and 300 meters. And also you can see the sounding accuracy is 1 centimeter and the beam angle is 5 degrees. And it supports automatic storage. The memory is 16 gigabytes. Okay, someone asked, without installing Oscar or Luca, currently the DAC can't be used with onboard GENS antenna because there are no RDK boards or RDK receivers in it. So you have to use an external GENS receiver. For example, Oscar and Luca, or Oscar TAPs. Okay, let's move on. Here is the intelligent controller. Its system is Android, and the screen is 7-inch, and the waterproof level is IP67, and it also supports fast charging, and its functions is as follows: switch option, operation mode, control USB speed steering, and it supports real-time display positioning, depth, video, USB battery level, and so on. Uh, the DAC provides a fast and portable solution to perform bathymetric service in race environments such as rivers, lakes, reservoirs, and coastal areas. Okay, let's let me introduce the Tersus Captain software. It's used to remote control the USB. Here is the interface of it, main interface. It supports real-time display of sensor status. You can click this icon to check the sensor status, and it will do a self-check after turn on. And here is the mission mode, manual, auto, and so on. And this is the message. You can check a message and log here. And this is the GNSS status, fixed float, and the satellite number. And here is the water depth, and this is the speed, and it's the battery level. And also, you can check the video here. Okay. It has a lot of function. For example, you can uh, switch manual hold, mission, or return mode here. And you can click the plan icon to enter into the plan interface. Here is the plan interface. First is the file. You can upload mission files, for example, a KML file here. And you can add waypoints manually here. Add waypoints. Okay. Someone asked the echo sounder range. It's also like the Oscar. You need to confirm the range before shipment. It's the hardware difference. The hardware is different. Is different. So you need to choose what you need. For example, 100 meters or 300 meters. Okay, let's continue. And after at waypoints, you can uh, upload the mission, and the USB the DAC will move automatically. And here is the load planning. You can click pattern here and click chess. After you add 3 points, it will automatically generate the route. You can set the spacing, the angle, and the turnaround distance here. You can also set a geo fence here, a polygon fence or a circular fence. And here is also a demonstration of the video operation of the Texas Captain software. Let's see the video. After you click the icon, you can connect the USB manually. But usually you don't need to do it, because after you turn on the USB and turn on and open the Test Captain software, it will connecting automatically, so you don't have to connect the device, the USB manually. battery status. Okay, here's the file. You can open a file here. KML format. The waypoint. Now we add waypoint manually here. After the work, you can click Upload Required, and then the mission will be ready, and you can let the USB run automatically. It will run from point 1, 2, 3, 4, 5, so on. And here's the route planning. Click Choose, and up you click 1, 2, 3. After you add 3 points, the route will be generated. And you can modify the spacing, the angle, and the turnaround distance here. Change the angle. Okay. After you upload the mission, you can slide to confirm. And after you slide, it will take off automatically. It's a similar operations of route planning, so let's ignore it. Okay, here is the geofence settings. You can add a Propulsion fence and a secure fence. Secure fence. Okay, here's the video. You can zoom in and zoom out. Okay, that's all of the video. Let's move on. Let's move to the binary part. Let me introduce the Marine Bench View software used to post-process the depth data. This software consists of 2 parts, Sonar Viewer and the T converter. Sonar Viewer can check and process the raw data files copied from the echo sounder, and the T converter can convert the WGS 84 coordinates results to your local projected coordinates after you enter the your local coordinate systems. So let's check the Sonar Viewer software first. It has raise functions. You can, after you import a raw data file, you can data playback. You can have a data playback, and you can batch remove frames, and you can also correct the depths. You batch correct depths, and you can also automatically check for suspected false data. You can click this icon to let it automatically check for suspected false data. And it also has some other functions such as marking. You can show bottom line and do depth filter. After the modify the edit of the data, you can export it using different various data format, such as CSV, TXT, or KML, and so on. Can you see Can you see the export interface? I will zoom in. Okay. You can select the GPS status, the sample distance, the unit, the sound speed, draft, height from antenna to water surface, and so on. You can set these parameters when you export it. And you can also add a tidal difference file here. Okay. After the export, let me check a CSV file example. I will also show you. Here are the WGS84 latitude, longitude, and altitude values here. It also has some other parameters such as fixed quality, sound speed, draft, antenna height, and severed altitude. Okay, after you export the CSV file, the software, the T-Converter software will be automatically open, and the CSV file will be automatically uploaded here. So you don't have to choose the file here. You can set your local coordinate system here and do batch transformation. This software can convert geodetic coordinates to any projected coordinates needed. Okay, here is a demonstration of the video. Let's check it. First, you open the software. You can see the Sonar Viewer and the T-Converter, the two software. And you open the Sonar Viewer software and open the file copied from the sounder. Click File, Open File, and select the file. The file format is TSL3, Texas format. And the left part is the trajectory, and the right part is the depth. You can click this icon to let the data play back. Or you can use your mouse to manually check it. And here are some parameters such as depth, speed, angle, and latitude and longitude, and the temperature. You can click bottom line here, and there is a red line. It represents the bottom. And the raise frame is obviously the data on the ground, so you need to batch remove them. You can choose remove frames here. You can manually enter the number, or you can select on the diagram. Select end frame. After that, you can click confirm, and the frames will be removed. Also, let's move another part of the data on the ground here. And you can also batch correct the depth. There are some data you can see uh, the depth is abnormal, is obviously abnormal, and you can move the red point here to best correct the depth. You can see move here, and the abnormal results disappear. Okay, move the red point, and the abnormal results will be removed, will be corrected. Okay, after the modify, the edit, you can save the files as a copy. And the next time you can just open the copied file instead of the raw file. After that, you can click export. You can set the format and the GPS status, sample distance, sounding speed just here. You can also choose the unit. Also, you can set the height from antenna to water surface here. Okay, after the settings, you can export the CSV file. And the T software automatically open here after you export the CSV file. And you can set the parameter here and then export to transformation to get the projected coordinates. You set the ellipsoid, the projection, and the plane adjustment and height fitting parameters here. Okay, after that, a DAT format file will be generated. And you can check the results here. DAT CSV. You can check it. It will be converted to local projected results. You can see here the local north, east, and the depth. And here's the CSV file. Okay. Okay, that's all of the video. Do you have any questions? You can type it here. Okay, or you can click this link to write your questions and send them to us, and we'll get back to you. Okay. If you don't have any questions, let's finish the webinar. Okay. Thank you all for coming to this webinar, and now we will stop the live streaming. Thank you for coming to this webinar. Thank you all. Thank you. I will stop.